You're lying in bed at night, hand on your belly, wondering, will they have your deep brown eyes or your partner's striking green? You've probably already imagined holding your baby, looking into their eyes for the first time, searching for pieces of yourself and your family reflected back at you. This isn't just curiosity, it's one of the beautiful ways we bond with our babies before meeting them. Wondering about eye color is universal among expectant parents, and it's a joyful part of imagining who this little person will be. If you're enjoying this, hit subscribe. We're here to support you through every stage. Today, we're diving into the actual science behind eye color genetics. You'll understand how those genes really work, why babies' eyes often change color in their first year, and how to calculate real probability percentages for what your baby's eyes might look like. We're turning genetic science into an exciting preview of your baby's arrival. The wonder of genetics gives us a window into your baby's future appearance. And yes, nature absolutely loves to surprise us. Let's start with something that might shift how you think about this entirely. Eye color isn't actually about having blue genes or brown genes sitting in your DNA like colored marbles. It's all about melanin. That's the same pigment that colors your skin and your hair. The amount and type of melanin in the iris determines what color those eyes will be. High melanin concentration creates brown eyes. Moderate amounts create green or hazel. Minimal melanin results in blue or gray. Think of melanin like paint pigment. The more you add, the darker and richer the color becomes. This matters because understanding melanin helps explain why eye color can change and why predictions aren't always straightforward. Multiple genes control melanin production. This makes eye color far more complex and interesting than those simple Punnett squares you might remember from high school biology. Your baby's eye color is being determined right now by a sophisticated genetic orchestra, not a single instrument playing alone. Now, here's where it gets really interesting. We used to think brown was simply dominant and blue recessive. Check the box, get the answer, done. But modern genetics reveals at least 16 different genes influence eye color. 16. The two main genes are OCA2 and HERC2, but others contribute to the final result. OCA2 controls melanin production in the iris. HERC2 acts like a switch that turns OCA2 on or off. But then you've got other genes tweaking the shade, the intensity, the patterns. This explains why two brown-eyed parents can absolutely have a blue-eyed baby. It's not a mystery or a mailman joke. It's genetics. Both parents can carry recessive blue-eye genes that they pass down together. This also explains why predictions are probabilities, not certainties. The science here empowers you with realistic expectations. Genetics is sophisticated. Your baby's eyes will be uniquely theirs, possibly surprising everyone, and that's completely normal. Here's something that surprises a lot of new parents. If your baby is born with blue eyes, don't order those birth announcement cards declaring your blue-eyed beauty just yet. Most babies of European descent are born with blue or gray eyes because melanin production hasn't fully activated. The iris needs light exposure to trigger melanin development. Your baby spent 9 months in darkness. Their eyes haven't had the chance to produce their full melanin potential yet. This is completely normal and doesn't indicate the final color. Whatever color you see at birth might transform completely over the coming months. And that's a normal part of development, not a concern. Some babies born with slate blue eyes end up with rich brown eyes by their first birthday. Others stay blue. The newborn eye color is just the opening scene, not the whole story. So, when will you actually know? Eye color typically solidifies between 6 to 12 months, though changes can continue until age 3. The most dramatic shifts happen between 3 to 6 months, when melanin production really ramps up. Think of it like a photograph developing. At first you see the outline, and then gradually the true colors emerge and deepen. Babies born with darker eyes, brown or dark gray, usually keep them. The melanin is already present and active. But light-eyed newborns? They're the wild cards. Some eyes that appear blue at 6 months will shift to green or hazel by 18 months. You might notice the color looks different in various lighting or seems to be changing week by week. That's melanin production doing its work. This timeline helps you understand when you'll know for sure and gives you realistic expectations for those monthly photo comparisons you'll inevitably make. Save those newborn photos because you'll want to see the transformation. Now let's get specific. You want numbers. You want to know your odds. Here's where we calculate your baby's probability percentages based on your eye colors and your partner's. These aren't guarantees, but they're scientifically grounded predictions. Two brown-eyed parents, 75% chance of brown eyes, 18% chance of green, 6% chance of blue. But that blue is only possible if both of you carry blue eye genes. If blue eyes run in both families, those recessive genes are likely swimming in your gene pool. One brown-eyed and one blue-eyed parent, 50% chance of each if the brown-eyed parent carries a blue gene. Otherwise, nearly 100% brown. Brown is more dominant. But it's not absolute. Two blue-eyed parents, 99% chance of blue eyes. There's a tiny possibility of green from modifier genes, but blue to blue almost always equals blue. Two green-eyed parents, 75% green, 24% blue, 1% brown. Green is fascinating because it's actually a combination of low melanin plus light scattering effects. One brown-eyed and one green-eyed parent, 50% brown, 37% green, and 13% blue if the brown-eyed parent carries recessive genes. Without those recessive genes, you're looking at mostly brown. These percentages acknowledge that family history matters deeply. If blue eyes run in your brown-eyed family, those recessive genes are absolutely present. They're just waiting for the right genetic combination to express themselves. Your baby could be the one who brings back great-grandma's striking blue eyes that skip 2 generations. Speaking of family history, this is where you become a genetic detective. Look at grandparents, siblings, and extended family. Recessive genes pass down silently for generations. Then surprise everyone. If your partner's grandmother had striking blue eyes despite a brown-eyed family, those genes are swimming in your baby's DNA pool right now. They didn't disappear. They've been traveling through the family tree, waiting. This isn't fortune-telling. It's recognizing that genetic inheritance reaches back generations. Your baby isn't just a combination of you and your partner. They're carrying genetic information from your entire family tree. That's why a baby might have eyes that don't match either parent, but look exactly like a great uncle or a cousin twice removed. The comfort here, however your baby looks, they're a beautiful combination of your entire family tree, not just the two of you. They're carrying forward your family's story in their very eyes. But here's the beautiful truth that matters most. Even with all this science, genetics loves to surprise us. You can calculate probabilities and study family photos and make predictions, and then your baby arrives and has eyes unlike anyone expected. Hazel eyes can shift between colors depending on lighting and mood. Some children develop heterochromia with two different colored eyes. Eye color might feature stunning patterns or rings that don't match either parent exactly. This unpredictability isn't a flaw. It's the magic of creating a completely unique human being. Your baby's eyes will be theirs alone. They might have your brown with your partner's gold flecks. They might shift from blue to green to hazel over 2 years. They might surprise you with a color combination you've never seen in your family before. And whether they match your predictions or surprise you completely, that first moment of looking into them will be perfect. Because here's what the science really tells us. Yes, genetics follows patterns. Yes, we can calculate probabilities. But every baby is a unique genetic creation. Those eyes looking back at you will belong to your child, reflecting not just genetic inheritance, but the remarkable fact that you created a completely new person, someone who's never existed before and will never exist again. The eyes you've been imagining during those late night wonderings, they're developing right now. Melanin is being programmed, genes are expressing, and in a few months, you'll look into those eyes for real. You'll see your baby, not percentages or probabilities. You'll see the person you've been waiting to meet. And whatever color they are, they'll be exactly right. they'll be your baby's eyes. Perfect for them, perfect for you. A beautiful window into the unique human you brought into the world.